This video covers section 9.4, simplifying radical expressions using properties of radicals. Objective 4, multiply radicals with unlike indices. This entire section 9.4 has been about having radicals with the same index. What do we do if we have different indices or a different index? So we already know that if the nth root of a times the nth root of b is given, then we can just assume them all under one radical because they have the same index. But if the index is different, we write the exponents back as fractions and use properties of exponents. So cube root of a times the fourth root of a, we cannot write that as a single radical until we write it as a to the 1/3 times a to the 1/4. Cube roots are exponents of 1/3. Fourth roots are exponents of 1/4. Properties of exponents say to add the exponents. 1/3 plus 1/4 is 7/12. And then you can put this back as the 12th root of a to the 7th. Now we have a single radical. So remember, the rule of thumb is when you start in radical notation, end it in radical notation. Example 9, multiply and simplify. Assuming that all the variables are greater than 0, the square root of x times the cube root of x squared. We write the square root of x as x to the 1/2, and the cube root of x squared as x to the 2/3. Now we add those two exponents together, and we get common denominator of 6, which is going to give us x to the 7/6. We rewrite this back as the 6th root of x to the 7. Now the example problem I did, the power was smaller than the index, so I didn't need to do anything with that. But when the power is bigger than the index, we divide 7 by 6 and get a whole part of 1, so 1x comes out, and remaining x stays under. So that's going to happen if your exponent is bigger than 1. Letter B, we have the 4th root of 4, or 4 to the 1/4, and cube root of 5, which is 5 to the 1/3. So this one's a little bit different. This one we don't have the same base, so we can't add those exponents. But if we get them both to have the same denominator, then what we have is both of them being 12th roots. So this is 4 cubed to the 1/12, and this is 5 to the 4th to the 1/12, or now both of these are to the 12th root. 64 times 625, so this is the 12th root of 64 times 625. Which is 40,000. 12th root of 40,000. Now that seems like maybe we could simplify that, but we would have to have something to the 12th power underneath that to simplify, and we know that we have 3 4s or 6 2s, and then we have 4 5s, so we won't get any perfect 12th powers underneath that. And here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. To get these all under the same radical, we write them both as exponents, x to the 1/4, x to the 1/3. Because they're like bases, we can add their exponents. 1/4 plus 1/3 is 7/12. And so we rewrite that back as the 12th root of x to the 7th. Remember, if it starts as a radical, put it back as a radical in the end. And letter B. We have 5 to the 1/4 times 3 to the 1/3. We can't add those exponents together because they're not like bases, but if we get a common denominator, now we can say that those are both 12th roots. 5 cubed to the 1/12, 3/4 to the 1/12. So we make them both to the 1/12, and we have 5 cubed is 125, and 3 to the 4th is 81. So that's the 12th root of 125 times 81. $10,125. So we have the 12th root of 10,125. And this concludes the video for section 9.4, simplifying radical expressions using properties of radicals. Objective 4, multiply radicals with unlike indices.